Thanks. Hi, everyone. Thanks for coming. Coolness. Hello? Yep. I'm Roger. I work at Netflix. I'll be talking about Vegas. It's a visualization library that we wrote in Scala for specifically the notebook use case. So if you guys usually use notebooks with Scala, like say Jupyter with Scala, and have been looking for a visualization solution, this might be the solution for it. Cool. So I work in the recommendations team at Netflix. Netflix, for people who don't know, it's a streaming video service that allows you to watch TV shows and movies, like for a small subscription fee. And these are some snapshots of recommendations that you, as soon as you log into the Netflix experience, you'll see these listing of movies. And every aspect of the recommendation experience is machine learned. So these are personalized and specifically created for your own unique taste. Additionally, Netflix is in 190 countries, so that makes it slightly challenging to incorporate demographics like country and cultural tastes to come out with personalized recommendations. Netflix is also present in a plethora of platforms, like either there's a client or an app for the smart TV that you're using, or iPhone, iPads, things of that kind. And that also adds a lot more parameters to tune when we come out with these recommendations for you. Like we've usually seen that people tend to consume a different set of content if they are on the mobile phone as compared to if they are watching something on a bigger screen. So that adds it over there. This is, again, just a screenshot of how the recommendations look at Netflix. Recommendations look in Netflix website. So each of these rows, they serve a specific purpose, and they are powered by their own machine learning algorithm. And on top of these row algorithms, there's a page construction algorithm that tries to reorder these rows in a way to optimize the subscriber's content consumption. And so as you could see, like, machine learning is an integral part of recommendations at Netflix. And after having done recommendations for almost after having done like machine learning for almost a decade at Netflix, what we realized was we were spending a lot of our time in the experimentation phase as compared to the productionization phase. With productionization, I mean the point when your machine learning models are baked in, you know what features you're using, and you're using those models to generate recommendations that are served to actual users. So whether that be actual production or in an A/B test, if you have baked in those particular things, then you have moved into productionization. But most of our time is basically spent in the experimentation phase. And it looks something like this, like a product manager would come in and basically come up with a problem which would be mainly improving recommendations for a small fraction of users that we are looking at. So it might be, let's improve recommendations for non-English speakers. And then we would go try to explore the data, try to identify what are the signals that we could feed into our machine learning model. And once we have trained a model, evaluate the model, see how the rankings look like, see how the Netflix homepage looks like with the newer model, share those findings, get some feedback from people, go around that particular loop again. And what we saw is in the experimentation phase, what works really well is the usage of notebooks. I mean, it's a great way of sharing ideas, like visualizing the output of your machine learning models, looking at metrics, slicing them, and then sharing it with people. Like, really is an easy process. Plus, right now, with all the tools that are present, like you could do an end-to-end ML experiment, see the results, then then people might provide you with some feedback about, I want to tweak this particular hyperparameter, rerun that experiment, and see how the results look like. It's a very seamless experience in that particular aspect. So in the Python ecosystem, the notebooks use case is well executed. I mean, if you search on the web for a gallery of IPython or Jupyter Python notebooks, you'll get like these beautifully crafted notebooks where people are trying to share ideas about some scientific idea that they might have. And the two main reasons why it works so well in the Python world is mainly because Python has these well-adopted scientific computing libraries like SciPy, NumPy, like sklearn and things of that kind, which makes it really easy. And the other second aspect is there's a plethora of visualization libraries that are present in Python, which makes it really easy to visualize your results. But on the Scala notebook side, like whatever solution you might be using, Zeppelin, Jupyter, like Spark notebooks, the computing library gap is filling up like a lot more with, like even people end up using Java implementations like through Scala, or MLlib is also filling up a lot of statistics-oriented techniques that you would want to do. But right now, there's a huge gap in terms of visualization libraries. Like, so on Jupyter Python side, Jupyter Scala side, like we don't have anything. On Zeppelin, they have some inbuilt visualization, but you really have to shoehorn your data to visualize the way you want to. So mainly to fill the visualization gap over there, like we developed Vegas, which is a visualization library in Scala. And this is mainly to fill the gap of visualizing things on the notebook. So mainly, what is Vegas? As I say, it's a visualization library in Scala. It provides a declarative API, contrasting it with an imperative API. So the API mainly tells the library like what you would want it to do as compared to how exactly you want to do. And that allows the underlying stack to make sensible, like pick up sensible defaults for you and visualize things in a very creative and meaningful way. And the other part that Vegas provides is like statistical operations. So the main thinking over here is your data is present in a tabular format, and then you usually just tell Vegas what dimension or what column of the data you want it to be the x-axis, what you want to be the y-axis. And then in addition to that, there are also statistical operations like filtering, aggregation, facetting. I'll talk about what facetting is in the next few slides. So it has support for statistical operations. Vegas is built on this concept of visualization grammar, where the idea is that we provide you a couple of blocks, and then you arrange those blocks in a way that you want to come out with your own creative visualizations. So I'll talk about, and the visualization grammar is, I mean, it's based on this idea called as grammar of graphics, which was popularized by this author Leland Wilkinson. And the main idea over there is that your graphs or your charts are composed of these layers that you see over here, and you can configure these layers the way you want to come out with the visualization that you need. So at the lowest level, you would have your data. You would tell the visualization library where my data is, and then aesthetics is basically just saying like what the x-axis, what the y-axis. If there is a color that you want to encode for a particular dimension, that's the information that you provide at this particular layer. And similar these other ones too, where geometries is basically whether you want a bar graph, a scatter plot, a bubble plot, and things of that kind. So it just comes down to configuring these layers and then coming out with the chart that you actually want. So this slide is just about like what are the levels of configuring that every layer presents you. We'll take a look at a specific example of this. So this is how a Vegas chart looks like. And there's this concept of channels in Vegas where, so channel is any visual variable that you want to modify to convey something meaningful. So like say X and Y are a channel. So you have some data and you have said that my miles per gallon column corresponds to the Y channel, horsepower is the X column, You could also change the shape of the actual data points based on a specific column. So you have used the origin column to come out with these different shapes. And similarly, you have again used the origin column to pick up a different color for that particular chart. So I'm just reusing the columns over here. This is not something that you would do for your own charts, but this is just to show like what are the things that are available right now. And then similarly, you could also change the size based on picking up a quantitative column over there. So here's the same chart, like it's computed using this particular data frame. Like you can see the various columns that are present over there, and the only thing that you do in the chart is you just say my x axis corresponds to this column, my y-axis corresponds to this column, and I want to use the origin column over here to encode the color bits, and similarly size and shape. So that's what it is. So here's just things that you get out of the box by using Vegas. Like you can get bar charts, scatter plots, area plots. This one is called a steam graph, and bubble plots. So all of these are out of the box. There's also this concept of trellis plots where you can take a chart and segment it into multiple subplots, and each segment basically zooms in a specific set of data that you're interested in. So over here you have DVD sales versus worldwide gross, and then you're looking at the movie rating, segmenting on whether PG, PG-13, like how does the data looks like. There's also this concept of layers where you could stack a chart on top of the other to come out with even more meaningful ones. I'm just thinking, how much time do I have? 120, okay. Cool. So over here, what exactly is happening is like you just have a bar chart, and on top of the bar chart, you have created these, you have aggregated to max and created that as a layer on top of it. And similarly, you have another third layer where you could choose the Q1 and the Q3 quantiles, 25 and 75th percentile, where does that band look like, and superimposed on the chart so that you can communicate even more. So Vegas was built for the notebook use case. It works great with Jupyter and Zeppelin. You could also use it on the command prompt to visualize the kinds of data that you want, like say file sizes and things of that kind. It uses JavaFX to render graphics on the command prompt. There's built-in support for Spark, where you could basically point to a Spark data frame and then call out columns over there that you want to point to X and Y. So that's the additional. There's also, I'm just listing out like what's available. So there's advanced binning, like you could take basically a column and then bin them into different bins to visualize the data in the right way. Sorting of scales. If you want to use like, in addition to linear scale, like log scales or exponential scales, like you could use those two. There's a concept of custom transforms where, so Vegas has its own DSL where you could basically, this works very much like Spark with the column kind of a concept, in the sense you could point to a couple of columns and say, can you create me a third column using these two columns, which would be the diff of those or some formula that you want to provide. So there's support for time series, like you could have columns which are based on temporal data like date, days, month, things of that kind. As I spoke about statistical operations like aggregation, max, min. You could filter data before Vegas prints it out. All of the math functions which are available in JavaScript, you could use those to transform the columns in ways that you want. Descriptive statistics like quantiles, Q1, Q3 are also available. I mean, the way it works is you specify your code in Scala. Vegas then generates an HTML out of it, and then it renders it inline in the notebook using an iframe. Actually, I wanted to show some examples over here. So if you see, so this is a chart which is generated using this data, where you have 4 columns, like say the year, age, sex, and people. So now if you wanted to generate a faceted one, so say you could do encode. So this is what I meant by faceting of charts, in the sense like you could segment it on another column, and based on that you can create subplots out of it. Similarly, things like you could add additional color information based on the year. And here's another thing about how, so over here, like because you said that year is an ordinal column, an ordinal is similar to categorical column, just that it has order information in it. It chooses these gradients of color to come out with coloring for different years. But say if you were to say this is nominal, then it would just go ahead and choose different colors for it. So it's these kind of declarative specifications that you could do to come out with these charts. And it's very easy to also, so say I'm just picking up this particular chart over here, and then changing from a bar to a line chart would be. So understanding the API is also pretty easy, because you can think about these graphics as various layers that you have. And then what you are trying to do is just configure each layer with the customization that you want. So say you could also do something like this, and it comes out with these kind of ones. So when I send out these slides, basically there are these. There's this sample notebook also that we'll send it out, basically that shows like what's available in Vegas. Okay, cool. Let me just go back. So this is this stack for Vegas. Vegas is just a Scala binding on top of Vega Lite. This is the actual JavaScript library which is doing the heavy lifting. And so Vegas emits Vega Lite code or Vega Lite JSON, which Vega Lite in turn converts it to another great visualization library called Vega. And Vega in turn actually emits out D3 JS code, which gets rendered out. And so as you go up the stack, you would basically see that the abstraction or the declarativeness of the API increases. And as you come down, like you have more power, but things are much more imperative. And you could, you need to actually spell out like how you want the charts to be. So the small code that you have in Vegas like gets expanded into this verbose D3 JS code that might be there. So right now, I just showed you like what's available in Vegas, but Vega Lite has now introduced different levels of interactivity, like where you could just hover around a chart, like pick up a single point, and interactively you can get more information about it. You could also highlight a specific column of data points. There's another where you could basically do a paintbrush kind of an effort, like you could just move your mouse, your cursor around those data points, and everyone in your path would be lit up so that you could take a look at that specific data points that you're interested in. This is the list of contributors over here. I also have Jeremy from Netflix sitting here. Yep, so that was it. Thanks. Thank you.
I saw somebody on Netflix on Vega Lite. On the GitHub issues for Vega Lite, they had a pull request to bring in geospatial from Vega up to Vega Lite. It's after the 2.0 release. If I wanted to help add that to Vegas, would I just implementing Vegas or in Vega Lite? Like, would you pull a newer Vega Lite?
So if they pull that in Vega Lite, so Vega Lite, with every release, they also publish their JSON schema, which is the one that we use to generate like the API for us. So the only thing that we would have to do is like update the JSON schema. And if you're willing to contribute at that level, yeah.
It just includes a JavaScript library, yeah.
Yes. And yeah, you just increase the version number, get the JSON schema, and then you would have a newer version of Vegas doing that for you.
Any other questions?
You said it's on Zeppelin. It's on Databricks.
We haven't tried it on Databricks Cloud, but people have told us that it also works on Databricks Cloud. Usually people end up using their own custom visualization in Databricks Cloud, but yeah, I guess every notebook solution should work with Vegas. We mainly use it on Jupyter and Zeppelin. Okay, cool.
Anyone else? All right, thanks, Roger.
Thank you.